memorize.
I'll try to make sure that on the questions that do involve any kind of math, we'll use those in our review. And give you a chance to kind of review them out there. Okay, here's some definitions to start us off. What can be defined as anything that has mass and volume and is the substance of which physical objects are composed? Matter. Matter is anything that has mass and has volume is the substance of which physical objects are composed. What is a compound? It's a chemical combination of two or more elements. Okay? If I only have a single atom of hydrogen, I can't call that a compound. Okay? You have to have two or more elements. Okay? Now, if I had, let's say, an atom of lithium, okay, and I had those formed together in a compound, that would be a compound. Okay? It's a chemical combination of two or more elements. Okay? If this was another hydrogen atom, okay, and two or more, it doesn't matter whether they're different or the same. This would still be a compound molecule H2. Okay? It's going to have two or more elements. Okay? H3, the compound that shows up in nuclear reactions a lot. It's still a compound. Okay? Let's look at this. I have element 1, I have element 2. It doesn't matter what elements they are. This one has 4 valence electrons, and this has 1 valence electron. Which of these two elements is more chemically reactive, meaning that it can more readily mix chemical bonds? This one. The more valence electrons you have, the more readily it makes chemical compounds. Another advantage, this will tend to be more electrically conductive too, right? You've got more free electrons. These are, valence are free. So element A is most likely going to be a better conductor than element B. Okay? So the more valence electrons you have, the more chemically reactive it is, the more electrically conductive it usually is. Electrons in motion make up an electric what? Electrons in motion make up an electric what?
Force. Motive force.
Current. Remember we talked about at the beginning of class and said that the electrons are charged in motion and they're in motion. Electrons in motion make up an electric. The answer is current. Okay. The unit used to measure resistance is called what?
Ohms.
Ohms. This is the symbol for ohms. This is the symbol for L meter. I have 2 copper wires. Okay, they're the same length. They're both made of copper. One's a smaller diameter. One's a larger diameter. which of these two segments is going to have more conductivity?
Lower rather.
Right. Okay, the resistance is going to be lower here because we got more area. Remember, as we decrease the cross-sectional area, the resistance goes up. Let's say I have two conductors. Diameters are the same. Okay, so the cross-sectional area is the same. This one's that long, and this one's several times longer. Which one has more resistance?
Bottom.
Bottom one. This is the resistance is higher because it's longer. Okay. Now it's a small change. If you change the area, it has much more effect on the resistance, much more so than the length does. But if you do lengthen it long enough, the resistance will increase. Okay, so that's why in aircraft, engineers try to make the wiring harnesses as short as they can. Because the more wiring you add, the more resistance you add. You already got several miles worth of wiring in a typical 737, 747. You try to minimize it. What other material is used for wiring in aircraft? Copper is often sometimes used, but the more common element is what? There are some exotic materials that are used for certain applications, but aluminum wire is pretty common. Define a thermocouple. What's a thermocouple?
Two dissimilar metals that once they heat up, they kind of go away from each other and stops the flow. Metallic connection until it cools down again.
You're thinking of a thermal fuse, but you got the right idea. It is two pairs of dissimilar metal wires. Two pairs. And dissimilar metal wires that are joined on one end. Okay? And they generate a voltage. Now this is one metal, this is metal A, or metal 1, metal 2. And they're joined at one end. And as the temperature of the junction, as the temperature changes, okay, we have a differential voltage. A differential voltage that flows across the interface. Okay, because they're not the same material. Okay, so a pair of dissimilar metal wires joined at least one end, generates a voltage between the two wires that is proportional to the temperature at the junction. So that voltage between the wires changes as the temperature changes. And we can calibrate that to get a measurement of temperature. That's for the thermocouple. Any questions so far? Just jump in if you have a question. Don't let me go on if you have a question on something. Since alternating current constantly changes direction and intensity, what two effects take place in AC circuits that do not occur in DC circuits? Close. Inductive reactance and capacitive reactance. Okay? Reactance doesn't occur in DC circuits. You can only have reactance in an AC circuit. Let's look at this will be the last review question. I'll give you a few minutes.